All right, so I think we should go ahead and get started. So hi, everyone. Thanks for joining. My name is Nathan Piccini. I am one of the marketing managers here at Data Science Dojo. And today we have Ian Eisenberg with us. He is the head of data science at Credo AI. And he's going to be talking about building responsible AI. So Ian, before you get started, I should also mention that we will be having a demo at the end. So make sure to stay for that nugget. The GitHub repo is going to be made available and everything. So Ian, now, why don't you go ahead and get started?
Cool. Yeah, so the talk today is about building responsible AI, best practices across the product development lifecycle. We're really going to be focusing on what can the developers of AI systems do to bring responsible AI practices into what they're working on. So I'm Ian. I'm the head of data science at Credo AI. I work on building tools to support organizations to assess and govern their AI systems. So my path to working in responsible AI was a bit circuitous. My professional life started in academia as a cognitive neuroscientist. I trained during the so-called reproducibility crisis. This was a time where scientists from many fields recognized that studies weren't reproducing. In my own field of psychology, an impactful paper estimated that only 40% of papers reproduced. These revelations caused us to realize that the scientific process as currently practiced was less than ideal. Many studies weren't replicating a basic requirement for the accumulation of knowledge. My field went through a reckoning period. Scientists identified a host of problems that contributed to the poor science and irreproducible studies. Now, while some problems were statistical or scientific, others were institutional or technological. Journals liked flashy, surprising findings, which were less likely to replicate. Failed replications were rarely published, leading to the file drawer problem. An extreme focus on p-values created an obvious place for statistical manipulation known as p-hacking. In fields that relied on more complicated techniques, like my own cognitive neuroscience, problems could sometimes be traced to poor training, tooling, and implementation. Doing things the right way required additional statistical and software engineering skills, which were sometimes lacking in scientists who are experts in other parts of the scientific process. What I want you to take away from all of this is that the incentives and tools available to scientists subtly shifted field-wide practices that harmed how science was done. In response, scientists identified problems and are currently working on changing publication practices, creating new tools, and generally directing more resources to reliable science than surprising science. Maybe you can see where I'm going. The field of AI is in a similar inflection period. We have focused on optimizing our models for narrow performance metrics, and we've gotten really good at it. But those measures aren't the thing we care about. They are just a proxy. We care about making good systems. The metrics are just a simplification of that broader goal. Building responsible AI reflects an appreciation that we need to know more about our AI systems to ensure that they are working well. And up until now, our narrow focus has sometimes resulted in systems that fail to live up to their promises. How we can change things for the better is what we call responsible AI. So this talk consists of 3 parts. First, I'll introduce some principles that are talked about related to responsible AI. I'll then talk about a life cycle approach that ensures that responsible AI pervades in your process. And finally, I'll move beyond the high level and get into how developers can concretely bring responsible AI into their work. I'll introduce some tools that can support your practices and demo an open source assessment framework we are developing called Credo AI Lens. Excited to share that tool with you later on. I'll stop after each section to take questions, and we'll have additional time at the end. Okay, so let's start with the principles. So what is responsible AI? Many principles have been thrown around, and a consensus is starting to emerge, which often settles on these key tenets. For instance, fairness gets talked about the most. We want to ensure our systems are equally beneficial to all people affected by them. Other aspects like accountability are talked about less publicly, but are equally important to ensure responsibility for the AI systems we create ultimately leads back to human decision makers. However, the point of this talk isn't unpacking each of these aspects. They're important and evolving, but I'd rather focus on the reality that they are still rather vague. We've moved from the very broad term of responsible AI, but now we have to contend with other high-level terms. How can we do better? Let's look at a specific instantiation of the tenets I just introduced. Here we can see a proposal from the US standard-setting body NIST. It is similar to many others, but one nice aspect of this taxonomy is that they separate principles into 3 different categories: technical, socio-technical, and guiding principles. Technical aspects are largely function of the AI systems themselves. You can imagine automating them, creating safeguards and tests that reflect a, quote, robust or secure AI system. Most of you are probably familiar with automating accuracy as one component. That's the normal performance measures we all know and love. This category is the easiest to extend from current practices. We move from, oh, we're only measuring precision. Let's add in some adversarial attacks to test for robustness. More complicated tests for sure, but the direction forward is relatively clear. At the other end of the spectrum are guiding principles. Guiding principles are the highest level ethical principles that an organization aspires to and are often completely disconnected from day-to-day development. Sometimes there is an AI ethics or governance team that tries to apply these principles with varied success depending on their integration with the rest of the organization. In the middle, though, we have the most challenging aspects, the socio-technical aspects of the system. Understanding these aspects require technical expertise and assessment, but also requires human perspective. The challenge is connecting our principles with our technical tools. Moving from principles to tooling is often described as moving from principles to practice. The gap between what we ideally want and where our technologies and processes are is a principles to practice gap. I thought this was a pretty good slogan for our problem, but how do we cross it? We cross it by taking a page out of social science playbook. We need to operationalize responsible AI. That is, we need to describe each aspect of responsible AI, be it fairness, privacy, or whatever, in terms of measurable outputs that reflect aspects of these abstract concepts. We're not going to be perfect. The operationalization of the thing isn't the same thing as the thing, but if we are clear about what we are doing, we can make progress iteratively, rather than throwing our hands up because concepts like fairness are hard to define. Okay, so that's the end of the first section. I'd love to take some questions if anyone's raising hand or anything like that. Okay, if there are no questions, I'll just move on. So now that we've talked about principles, let's talk about where responsible AI fits into the AI development lifecycle. So often responsible AI practices start as a final check before deployment. If you're making use of responsible AI at all at your organization, it might be like this. You built your model using traditional practices, and at the end, you want to make sure that it is fair, robust, or whatever. This practice is cultural and organizational. If your company has a governance or ethics team, they might not be embedded in your development team, and so check in rarely. Alternatively, fairness may not seem like a critical component of your system, but as a risk mitigation step, secondary to the primary goal of the system. Given the limited buy-in, resources, or anything else, placing a responsible AI check-in at this point, right before deployment, is a good starting point. But what if something doesn't look right? All the incentives are stacked in favor of deployment, in favor of rationalizing away any issues. Are you really going to go back to the drawing board? To quote the biologist and statistician Ronald Fisher, quote, to consult the statistician after an experiment is finished is often merely to ask him to conduct a post-mortem examination. He can perhaps say what the experiment died of. It's much the same way with responsible AI when it's put at the very end of the development lifecycle. So what can we do instead? We can integrate RAI practices at every stage. Rather than becoming a check viewed as additional overhead, just becomes a part of development that ensures that the AI systems are as good as possible. So to do so, we move from this kind of holistic approach, and at each stage, we have actionable things we can do. There are specific steps that we can take. While we normally focus on development, equally important is defining the system's point, what we're actually trying to do, and figuring out how to communicate and monitor the system's capabilities after deployment. So the kind of TLDR here is that you need to evaluate the responsibility of your AI systems at every step. I think the main points that I want to highlight are that during design and deployment, there are things you can do that differ from the kind of assessments and model choices that you'll make during development. This is going to be a multi-stakeholder approach. In general, no single person either has the expertise or should have the responsibility for determining every aspect of the system. So let's get into kind of separating out these different aspects a little bit. So when you're designing the responsible AI system, a big part of what you're doing is aligning on what quote unquote good looks like. What are you trying to do with your system? And what does it mean for it to be a fair, or responsible, or just adequate? So the kind of questions that you might bring up are: who is going to be impacted? What are the potential negative impacts? Could there be a possibility of misuse? Are there going to be downstream uses of this model that aren't anticipated right at the beginning? Other things might be more specific. For instance, there's a growing regulatory context around many AI systems. Does that apply to this model? And ultimately, how do we measure and mitigate the negative impacts? We're kind of taking a security mindset. Instead of saying, kind of at the end of the road, asking, did anything go wrong? We're trying to think about all the possible ways that the system could be misused or lead to problematic outcomes. So there are a lot of tools that actually help with this alignment process. It's sometimes quite difficult and can take teams many hours. It requires different stakeholders to kind of come together and align on their philosophical underpinnings, connect that philosophy to the goals of the company, and then break out those goals into an actual assessment plan, something specific that connects to how you're actually doing your AI development. So there are some tools that help. We've already talked about one source of alignment. So that's industry standards and regulations like NIST. These are definitely helpful. They help standardize expectations and providing needed perspective to your organization. But they won't connect to the specifics of your use case and probably aren't going to be enough. There are other frameworks, like those developed by Aquitas, which try to structure alignment as a series of questions, which can be helpful. So you basically follow like a little tree. They'll ask you different questions, and then at the end, they can tell you what kind of fairness considerations should you bring in. My own company, Credo AI, takes a somewhat broader approach. We recognize that alignment is necessarily a multi-stakeholder process that must result in both processes and an assessment plan for your AI system. Our product augments the expertise within your team to increase clarity, scale, and efficiency of your alignment process. I'm not going to go through exactly how it does that, but I'll just say that alignment and trying to understand the beginning of your system is kind of an ongoing research area that is different than what are the technological tools that you'll make use of given that you've aligned on the system. It's kind of the socio half of the socio-technical challenge of responsible AI. So once you've aligned, the next step is to actually develop your responsible AI system. And at this point, some of you might be somewhat familiar with some aspects here. So a simple one is including responsible AI metrics, either in your objective function or in the way that you assess your models. So for instance, I mentioned a long time ago now about evaluating not just your model for instance, precision, but also assessing it for robustness to adversarial attacks, potentially also using precision as your performance metric. Fairness has been defined with a host of different metrics, and trying to figure out which one is really part of the alignment process, but ultimately you need to bring it into your development process. Another thing that's become very important is recognizing that the model and the data set are of course part of one system, and you can often make good progress by just evaluating the data set itself. That actually might be the source of any problems in your data, in your ultimate system. And so evaluating your data is kind of a way of going to the actual source. The other aspects that we're talking about here are kind of related to any system. you want to be clear about which methodologies are important for you, which ones you're rolling out and for why, and documenting the decision process. I think this last point is probably one of the most important. In the end, any single use case is going to apply to many others. The learnings that you get from one are going to be applied in the future, and there's going to be an accountability train that is potentially necessary to deal with certain audits, or is just helpful to reflect back on why did you make certain decisions, so that after the fact you can kind of understand were they important or not. So I wouldn't dismiss just the importance of documentation. And finally, like once you deploy your system, there's of course plenty that you can do at that point. So many companies are incorporating kind of monitoring into their plan. They might be using things like looking for data drift, things that compromise the expected metrics that you would take from your model, because now you're in a data regime that you're not expecting. Incorporating responsible AI metrics is an obvious place there. Bringing in a kind of accountability audit into your approach, and just like kind of iteratively checking in with your models, making sure that they're still serving purpose, checking to see if they're being used in novel use cases. For instance, if you've trained an embedding system, how are they going to relate to often the embeddings might be used in downstream systems that are outside of the purview of the original developer. Trying to understand that sequence is something good to do after deployment. I see these questions and I'll come to them in just a moment. The final point here, just having a plan in place if something goes wrong, is pretty important. Like oftentimes you might be blind to issues that come up, or if you're not blind, you might not know exactly what to do. Having, for instance, recourse available to users that might be impacted by your system. For instance, if you're making loan decisions based on your system, having some way for the humans that are affected to feedback their potential complaints to the system, have a way to roll back to previous systems. Kind of general good practice of reproducible machine learning is generally helpful for responsible AI. It's not a completely separate aspect of other kinds of machine learning development. Ultimately, it's kind of it's occasionally just a new kind of buzzword that covers building your systems well, and just ensuring that you kind of understand their deployment schedule, understand the data set that's applying to their decision having fallback. I'll stop there. And let me see with the questions. How do decision makers currently think about balancing risks versus having a big PR team? Not sure what the verse here is, but one of the risks that maybe you're alluding to is that one of the incentives for any organization to engage in responsible AI is to mitigate kind of poor PR. So no company wants to be found out to have an impactful ML system that is not fair, for instance, or to have a data breach where private information can be discovered through membership inference attacks or other kinds of privacy attacks. So I think I see that as kind of articulating that connection between poor model performance or poor responsible AI practices and the bottom line for the company, which may be poor PR, to be a critical aspect of making responsible AI not just an ethical choice, but a kind of obvious one for a bunch of different reasons. I hope that answered some of that question, but feel free to add another one if you're if I didn't touch the heart of it. And the other one, what background training did you go through to convert yourself? I'll answer that one at the end if I'll have time to talk about just my own career at that point. Okay, so what I've tried to set up, okay, this is an interesting question. To check responsibility at every step, how is increased complexity managed? So I think this is where good tooling comes in. Right now, when a company tries to bring responsible AI into their development, oftentimes this ends up with a ton of overhead. At the very beginning, you might have just the challenge of trying to understand, what does fairness mean for machine learning systems? And what does it mean for your own organization? That might be hours and hours of meetings that then need to be documented somewhere into a game plan. But every time that you have a new use case, it's not exactly clear how to bring those previous discussions into bearing on this new use case. That's just one example. Other aspects are just your tooling might not support responsible AI assessment. The regulatory landscape, which is definitely connected to responsible AI, is evolving, and it's not clear how both to audit your systems to be in compliance or to even know what regulations you have to be compliant with. I'm just articulating Abhishek's, like, what's underlying Abhishek's question, which is there are many aspects that are going to potentially lead to more complexity. I think where we are is at an inflection point where tools are being created or integration points are being created that will make this a more seamless process. So obviously at my company, what we're doing is trying to reduce this overhead as much as possible. Some companies, for instance, have an AI governance team, which handles a lot of the responsibility for articulating the processes and requirements that are needed. But in those cases, they have difficulty interacting with the developers in a seamless way that doesn't either feel like a checkbox ticking exercise or doesn't connect to how the developers are doing things. I'm actually going to show why I think open source tooling is one aspect that makes responsible AI, I mean, it's kind of a growing part of the ecosystem that makes responsible AI assessment and practices more approachable. And Lens, the tool that we're building, is one aspect of making it relatively easy so that there's not much overhead. Okay, let me see what other questions are coming up with these practices. Okay, so Andres asked, would these practices include the analysis about avoiding data or model hacking? Hacking is a kind of broad word here, so I'm not exactly sure what you're referencing, but there are aspects that are sometimes talked about as robustness or privacy preserving or security. These phrases, I think, connect to different aspects of hacking. So for instance, being able to interrogate models' output and discover data, discover the data that was used to train the model, using poisoning attacks that could corrupt the model's outputs, or just generally figuring out kind of adversarial examples that can distort, basically move outside of the training regime of the model to get it to perform quite poorly. All of those aspects are within the purview of responsible AI, and there are tools that are being developed to make kind of observing those issues easier. I will say that one thing that's interesting about responsible AI is that it is both, we need better tooling, we need better practices, but in some cases, it's literally a scientific problem as well. We don't exactly know every way to safeguard our AI systems, particularly when they become very complicated, like large language models, like GPT-3, if you're familiar with those kinds of models. But the tool system is growing, the scientific process is expanding, and I think they're helping there. Wiseman, which certifications would you recommend for stakeholders to have confidence in the security of their system, e.g. against a data breach? So I'm actually not as familiar with data security. That's definitely connected with what I'm talking about right now, but I'm just not familiar with the ecosystem. I'll just say that there's while approaches need to evolve, certifications are one aspect to kind of simplify this whole system to allow other stakeholders like vendors or people buying a product to simplify the due diligence they need to do. And that often takes on the approach of, for instance, like SOC 2 is a security certification which has certain compliance requirements. I would imagine that in the coming years, for data breaches and potentially other aspects of responsible AI, we'll see certification bodies either coming from the nonprofit sector or maybe some for-profit institutes, or maybe even mandated by certain governments. But I don't think we're quite there yet. Okay, well, thank you for all the questions. I'm going to move on now to both talk about Credo AI Lens and also some of the tooling that I was referencing when responding to this question. So we've talked about multiple steps you can take to embed responsible AI processes into your development, but I want to get more specific and not just stay at that high level. A lot of what we've talked about could apply to other complicated systems and aren't necessarily specific to AI systems. So what makes AI systems special? Well, my answer to that is that they are amenable to assessment. That is, we are able to measure aspects of AI systems that gives us an unprecedented view of how a complicated system operates. Assessment is the foundation of any other practices we're likely to adopt. We can only manage and govern systems that we can understand and observe. So the perspective I'd like to bring here is that while sometimes we talk about black box models that are hard to interrogate, I would argue that even black box models are easier to understand than comparable systems in the past. If we just take LinkedIn as a hiring recommendation engine, that's a complicated model. Hopefully it's not black box within LinkedIn, but it's certainly black box for those of us outside of it. And assessing it might be difficult. But if we compare that to a previous system, which was just distributed hiring that went through networks of people, clearly LinkedIn system is more amenable to assessment. And I think that's the place where I'm optimistic that we will continue to get better. There's a road to getting better at understanding these AI systems. So there's actually a vibrant ecosystem of open source responsible AI tools. So I've listed some of the most popular here, but smaller tools are being developed all the time. Some big players are actually contributors to this ecosystem. For instance, IBM and Microsoft and Google all have open sourced some of their responsible AI tools, probably for the purpose of just expanding these practices in the general ecosystem. Some of more specific tooling, like SHAP and Lime, which are explainability tools that you might be familiar with, have become ubiquitous and maybe have led to some people kind of resting on their laurels and trying to figure out new ways to explain systems, but are remarkably powerful. Other tools that you might use already aren't exactly responsible AI tools. They're just part of the broader data science ecosystem. But I think that they, you can see how they can be part of a responsible AI process. So for instance, Pandas Profiler makes exploratory data analysis really easy, which is just important to have, as any good developer knows. SDV, which is the synthetic data vault, lets you make use of approaches like generative adversarial networks to synthesize new tabular data, probably also visual and language data as well. And that can help you with potentially data blinding or increasing the robustness of your models. There are other tools like YLogs, which helps with data tracking. Basically, there's like a nice open source community. However, one issue with the open source ecosystem is ease of use. It's often difficult to know which responsible AI tools actually exist, let alone how to integrate them with current workflows. So it's this kind of understanding of the overall ecosystem and approachability that we have tried to tackle with our own offering to the open source ecosystem, which is Credo AI Lens. So Lens is an assessment framework that provides a single standardized point of entry to the broader responsible AI ecosystem. With Lens, developers have easy access to a curated ecosystem of assessments developed or honed by vendors and the broader open source community. We also create our own assessments, but we want to make sure that you have access to, for instance, Microsoft FairLearn, which is basically best in class fairness assessment, and make these all easily accessible. So before I get to the demo, I'm just going to break down what's going on under the hood in this Lens ecosystem. So Lens starts with a module library that is composed of tools we've built, as well as wrappers around open source tools like those listed on the previous page. So the Adversarial Robustness Toolkit, FairLearn, Chaplain, etc. So a challenge for the ecosystem is that every model and data set is different, and each module has different APIs. These features make it hard to set up a generic system. It's hard to connect your model to every system. You might spend a long time trying to figure out how to connect your data and your model to IBM, for instance. There are some standards that are developed around kind of scikit-learn's API or Pandas API, but still, it's often a headache. So to deal with these issues, we introduced some lightweight wrappers that go around models, data sets, and modules, which we call Credo models, Credo data, Credo assessments. So these three wrappers allow you to connect your model, your data set, and this library of modules. And what's more, because they help us understand whether your model or data set connects with a particular module, it allows us to do automated recommendations of modules that will apply to your system. This framework is also extensible. So new modules can be added and wrapped in Credo assessments. You can even add your own custom assessment scripts into the general framework. We really don't want to create a closed garden here. The goal is really to create a standard where you can basically use the same code, for instance, a year from now, and get access to a new, better set of modules and connect your own potentially in-house assessments to this overall system. So the current Lens capabilities we're in active development here include fairness assessments. So this is like an easier to use integration point to FairLearn, data set assessments and data set profiling, some aspects like custom natural language processing assessments, which I'll show you in a bit, that allow you to look at the generated if you're building a language generation model like GPT-3, you can assess it for toxicity, profanity, etc. On standardized benchmarks, and of course just general performance assessment, which can be disaggregated. So I'll jump to the demo and then happy to take questions. Okay. So in the a slide deck, which will be shared after this, you can find this documentation and the GitHub repo. But basically, you're seeing the same thing that I just showed you. That Lens connects Credo models, Credo data to a set of assessments and then creates a number of reports. All of this is connected with Credo AI's governance platform, which helps to deal with some of the other aspects we talked about before, for instance, alignment, overall monitoring, making sure that your system, that you have kind of eyes on all of your systems. This is not open source, so I'm just going to focus on the open source assessment, which doesn't actually need to necessarily connect with the overall governance platform. So the way this works is, let's say you've run some training. So here, this script here, it's the thing that created your model, created a data. It might not actually be data. It might be data. So just imagine that you have done some development of some kind that created a model and a data set, and now you are interested in assessing the system along a number of different dimensions. The way you do that with Lens is encapsulated in this cell. This does everything here. So here we have the wrapper around Credo model, around the model. So this Credo model infers a decent amount from this model. For instance, in this case, the model is a gradient boosted classifier, and that is inferred and allowed to kind of communicates its functionality. We have the data set, and the main important aspect here is what is the sensitive feature. So in this data set, sex is there, and we're interested in the fairness of the system. The next stage is just articulating the spec, the kind of assessments we want to do. So this is the way to separate out the alignment stage of responsible AI, where you kind of figure out exactly how do you want to assess your system and create a spec for it. So in this case, for fairness and performance, we want to look at precision score, recall score, and equal opportunity, which is a fairness metric. And that's it. From there on, you just can put them all into Lens, you run the assessments and display results, and you'll see what happens below. So the first aspect is Lens is going to automatically figure out the assessments that it can run. In this case, it can run data set fairness, it can run data set profiling, and it can run a fairness and performance assessment on the models. It's then going to kind of calculate different aspects and display the results. Those are going to create some reports that we're not going to go through right now. The basic time that's being spent right now is actually on the data set fairness report, which is fitting a model to estimate whether there's information in the of the protected attribute sex in the rest of the data set. So it's a measure of redundant encoding. And what we get from that is a number of different results. This is how they're displayed from the data set fairness, from some plots. Here we're just to use data set profiling. We just use pandas profiling, so that's taken care of here. And as we continue going, oh, I'm scrolling on the wrong thing. As we continue going, we can see performance metrics, fairness metrics, and some other performance plots that are created. So this is all available. You don't have to display it. It's all kind of available to you here. And to make this a little less overwhelming, you can see that, for instance, we get things like the parity measures for precision score, recall score, or disaggregated performance. So we get precision score separated from female and male. So a lot of things that potentially you're already making use of in some of your assessments, plus some that maybe you aren't. Maybe you're not actually making use of fairness, and all of that can then just be, done in this kind of way. An important aspect here, though, is that while these assessments were run because of this model and this data set, different assessments would run for different assessments. So I'm just going to go to another one of our demos here. This one is in our documentation, so it won't be live run. But what we see here is what I referenced before, assessing language generation models, and using the same. Let's see, where is the code? Using the same essential code, where you set an assessment spec, you define the model, and you run the assessments. What you get here is an assessment of your model. In this case, I think it's GPT-1, taken from Hugging Face, and measured for insult, profanity, threat, and toxicity, and compared to another language generation model. And because the data set, the benchmarking data set that we're making use of, has access to protected attributes, including different religious groups, we can disaggregate there. And again, look at insult, profanity, etc. for these different groups. So what Lens has given you is a common interface, just running this kind of thing, that can automatically select from a large range of different modules, and then just run them. And it can create reports, which I'm not going to cover right now. And if you use Credo AI's governance platform, it can export to that, etc. So with that, I'm going to stop there. Thank you all for attending. I'd love it if you checked out Lens. We're in active development, and would appreciate any feedback issues or success stories. I think the links are going to be sent out afterwards along with this deck. And yeah, thanks for attending. Happy to take questions.
All right. Well, and while people are typing, do you want to talk about, what background you have coming from a neuroscientist to data scientist?
Yeah, sure. So my background as a neuroscientist and psychologist basically led me to, I trained at Stanford, and so AI was definitely in the water there. And I learned a number, just being a scientist kind of relies on the same skill set that data scientists rely on. So I was very familiar with kind of pandas and scikit-learn, and et cetera, while also learning about convolutional neural networks and PyTorch and all of those other skills. And after I graduated, I worked at a building recommendation systems in a software engineer hiring company called TripleByte. And that gave me perspective both on the actual day-to-day of being a machine learning engineer, as well as the challenges of dealing with such a potentially high-risk area like hiring. In my time at Stanford and my time at TripleByte, AI risk, AI safety became more important to me. And I actually also got involved in this movement called effective altruism, which helped me figure out what problems I wanted to work on. And from there, I decided, like, now with this combination of a social science background and as a machine learning engineer, that was the most difficult transition point. I then just learned a lot about responsible AI and AI safety, and joined Credo AI in June of last year. So it was the transition from neuroscience to industry. I think a lot of academics find that to be a somewhat difficult transition. For me, it was a little difficult, but after that, it's been fairly self-driven.
All right. And does anybody else have any other questions? Like Ian said, we will send his slide deck out when we have the recording available on our website. So you will get all the links to this. I think our team's already sent out the GitHub link so that if you want to check that out, you can. It's not looking like we have any other questions. So Ian, thank you so much for being here with us today. And whether you joined us on Zoom or LinkedIn or YouTube or Twitter or Facebook, thank you for joining. Tomorrow, we will also have a one of these community events going on at noon Pacific, so the same time as today. That is with Jeremy Adamson, the author of Minding the Machines, and he's going to be going over, leveraging the non-technical skills as a data practitioner to leverage relationships and reconsider roles and control the data narrative in your organization. So if you kind of want to learn how to, as a data professional, how to move your career along using non-technical skills, be sure to join tomorrow. And Ian, thank you again. We'll send you the recording when we have it. And thank you everyone as well. And I hope you have a good rest of your day.
Thanks everyone.